All right, this is for Michael and Riley, I think. I think that's it. But we are starting to fill out this box. We started to fill out this top box here, and I forgot that I needed to record. So write this down in the top box. This is the quadratic formula we'll write down. And the next thing, we're talking about like what the quadratic formula does. It finds the x-intercepts, which are also called zeros, roots, or solutions. There's that, okay? If you need to pause to catch up, go ahead. But we're going to go down to the bottom box, and it says the discriminant, okay? So let's talk about the discriminant for just a second. What is the discriminant?
B squared minus 4.
It is just the b squared minus 4ac. It is this part of the quadratic formula. That little chunk right there is b squared minus 4ac. That's what that is, okay? Now we're going to write some stuff in this next box over that talks about like what the discriminant does and what some of the things mean, okay? So if your discriminant is a positive number, what does that tell you? There's two solutions, right? And the two solutions come from the plus and the minus. That gives you the two numbers, right? Plus something, minus something, okay? Now, if I have two solutions, what does my graph look like?
That's the vertex.
Possibly. Nope. Two solutions. Two solutions means he's crossing twice.
Yeah, it's like that.
It's a parabola, so it's crossing twice. Now, could it be a frowny face?
Yeah.
Yeah, it can still cross twice and be a frowny face. That would work, right? But if it's a positive number for the discriminant, that means he's crossing twice. That means he has two zeros, okay? Now, if that number is, let's say, a negative number, what does that mean? Then there's no solutions, okay? What does my graph or my parabola look like if it's no solutions?
Then it'll be like
It's not
in the
touching
top
the
right corner.
x-axis at all.
It's like hovering above somewhere, right? It's not crossing at all. Could it be a frowny face?
Or below.
It could be like here also, right? One of those two things are happening. All right, I'm just going to write the top one, but that's what that looks like. And then the only other option is that your discriminant is 0. Now, what happens if your discriminant is 0?
It only has one.
Why is there only one solution if your discriminant is 0? Okay, now it doesn't cross at 0. If this number right here is 0 and you're taking, like, let's say 5 plus and minus 0, right? Isn't 5 plus 0 the same thing as 5 minus 0? You only get one answer, right? Okay, so that's kind of how that works. If you have one solution, it's only crossing once. Well, how does that work?
I told you.
That's right on the dot.
It's on the x-axis. This vertex is just touching and then it's going back up. Could it be a frowny face?
Yes.
Yes, it would just be below, right? Okay, could anything like that could happen, all right? So we can only have 0 solutions, 1 solution, or 2 solutions. Can you have 3 solutions for a quadratic function? No, like you would have to, in order to have 3 solutions, he would have to turn around and come back down, but that's not a parabola anymore, is it? Okay, all right, so let's go. We have like this chunk right here is referring to this example. Then we have a chunk down here that's referring to this example, and we have a chunk over here that's referring to this example, okay? So what I'm guessing is what's going to happen is you're going to have one of them that has 2 solutions, one that has 0 solutions, one that has 1 solution, probably, okay? All right, so let's do that. We're going to do these together. So let's go ahead and first they want us to calculate the discriminant, okay? So in this box, I'm going to do A, B, and C, and we're going to fill out A, B, C here. What's up, Josie? Yes. A, what do you have for A?
1.
A is 1, B is
10, negative 10.
positive 10. I think that's a positive number. I don't know if you can see the plus sign.
no, yeah,
It is a
plus.
plus, okay? Positive 10, and C is 25. Okay, so we want to calculate B squared minus 4AC, okay? And so B squared will end up being like 10 squared minus 4 times 1 times 25. Okay, so let's calculate this. What is 10 squared?
20.
100. 10 squared is 100. Minus, what's 4 times 1 times 25?
100.
Now, will that be a minus 100 or plus 100?
Minus.
Minus, right? Because there's only one negative right here. So what's 100 minus 100? 0. And so that means the discriminant is 0. The discriminant is 0. Okay, now let's talk about what that means down in the box right below it. What does it mean if our discriminant is 0? One solution. We're only going to have one solution. SOLUTION, or you can abbreviate solution SOLN. I don't care. One solution. He's going to have one place where he touches, okay? Now, they're wanting us to find that solution up here in this box. So let's do our quadratic formula, negative b. Negative b will look like what?
Oh, it's right.
Negative 10.
Negative 10 plus and minus the square root of b squared minus 4ac, but don't do any more work because we already have the discriminant. It is 0. All over 2 times a. There he is. Okay? All right, so let's simplify some stuff. There he is. There's my quadratic formula. What is the square root of 0? It's just 0, right? And 2 times 1 is 2. So what I have happening, I have two things happening. I have negative 10 plus 0 divided by 2. And I have negative 10 minus 0 divided by 2, right? I have plus and minus. What's negative 10 plus 0 divided by 2?
Negative 5.
Negative 5. What about negative 10 minus 0 divided by 2?
Negative 5.
Also negative 5, okay? So I have two answers, but they're the same answer, right? So since they're the same, I really only have one solution. Does that make sense? It's just negative 5, right? Okay, because adding 0 is the same thing as subtracting 0. Okay, now let's graph it. Let's see what he looks like on a graph. Okay, he is touching at negative 5, right? 1, 2, 3, 4, 5. There he is. And what about that? That's where the vertex is, right? He's just touching and then he's going up. Okay, now where is he crossing this line right here?
Somewhere way up there.
Somewhere way up there. According to the equation, where is he touching?
Positive 25.
Positive 25. How do you know that?
Because that's where the y-intercept.
That's the y-intercept. That's at positive 25, right? So we know all the way up here somewhere he's touching that line, right? Okay, so those are just some other things that we can say. All right, good? Okay, let's move on to the next one. Let's do ABC here. A equals?
If we do the means,
Yes, it means one solution. Right. Like just like what does that mean? Like not mean as in average. Mean as in like what does it mean, right? Means one solution. Okay? Can you wait to write this down? Yeah? Okay. What is A?
6,
6. What's B?
1,
1. C is
negative 15.
negative 15. Okay, B squared minus 4AC. B squared will look like
1 squared.
1 squared minus 4 times 6 times negative 15. All right, so 1 squared is 1, okay? Now, negative 4 times 6 times negative 15. Will that be a positive number or a negative number?
Positive.
Positive number. Okay, now, you can do this in your head, actually, but I wouldn't multiply 4 by 6. I would take, do you know what 4 times 15 is?
No.
Think of a clock. 4 times 15 is 60. Okay, now, can you take 60 times 6? 360, right? You can do some of these in your head, but you might not want to multiply them in the order that they're given, right? Like, I don't necessarily know what 24 times 15 is, right? But I know what 60 times 6 is. That's a little bit easier, right? Okay? So what's 1 plus 36? Or 360? 361. This is the discriminant. Discriminant is 361. So that means that I have two solutions. Why is it two solutions? Because positive. Because it's positive. Because it's positive, I have two solutions. 361. Okay? Now we're going to find those solutions. So we start with negative b. And what's negative b look like? Negative 1 plus and minus the square root of 361, right? We've already calculated b squared minus 4ac all over
12.
2 times 6. Or Johnny says 12. Okay, so let's figure this out here. I'm going to zoom in. Can I zoom in? What is the square root of 361? I didn't think it came out nicely. I thought 361 was prime, but it's not. It does come out nicely. 19.
It does?
It's 19. Yep.
I knew it was
Okay, all over 12. So I have two answers. I have negative 1 plus 19 over 12. And I have negative 1 minus 19 over 12. Do you guys see how that works? Right? Okay. Negative 1 plus 19. What does that become?
18.
18. What's 18 divided by 12?
I don't know. What is 18 divided by 12?
1 and 6 12, so 1.5.
1.5.
Or 1.5. I'm going to write it as 1.5 as a decimal. Okay. Negative 1 minus 19 is negative 20. And what's negative 20 divided by 12? Negative 1 and 2/3, so 1.6 repeating. Negative 1.6 repeating. That's what he looks like. Okay, 1 and 2/3, so 1.6 repeating. Let's graph. Let's look at the graph here. He is crossing at two places. I'm going to go here. He's crossing at two places, and they are at 1 negative 1.6 and positive 1.5. So about there and then a little bit over halfway, right? Okay? That's where he's crossing. Is he smiling or is he frowning?
He's smiling.
How do you know he's smiling?
Because there's no negative 1.6.
It's a positive x squared, right? Positive 6x squared. So he's going to smile. Now, where is he touching the y-axis?
0, -15.
Negative 15, right? Okay, so he's going all the way down here at negative 15. That's where he's located, something like that, right? Yeah, pretty well. Yep. Now, he actually is a lot skinnier than what I drew him as because, like, my units are not the right spot. But anyway, now, here's my question to you. Are you ready?
No.
Okay, is this negative 15, is that the vertex?
Yeah.
Yes.
No, it's not. It might not be.
Right here it's touching at 1.5. Right here it's touching at negative 1.6. So this guy is not exactly in the middle. Where is the vertex located in relationship to that point?
To the left.
It's slightly to the left. This is where the vertex will be located. So it's actually hitting negative 15 on its way back up. Does that make sense? Okay, that was a little bit more in depth. If that doesn't make any sense to you, okay, just skip over it. That was kind of an in-depth question. But anyway, that's kind of how that works, okay? That vertex will not be exactly at negative 15, okay?
We
All right.
last one by ourselves.
You want to try the last one by yourself?
Yes.
Yeah? Okay. I'll give you a 30-second head start, and then we're going to go, okay? 30 seconds you have. Go. 30 seconds. Okay, try it. Everybody try it. Reese, try it. Carson, try it. Ahmet, try it. Go. Start with your ABC, just like we did on the other ones, right? Start with ABC. Go.
Did you simplify though?
Would I simplify it? Yes, kind of. This one simplifies kind of nice. I'm guessing this one has how many solutions?
2.
0. We've already done a 2-1. We've already done a 2-1 and we've already done a 1-1. This one's probably going to have 0 solutions. Okay. So, well, kind of. Not really. Not really. It makes it harder, I think.
It's harder.
I think it's harder if it has 2 solutions.
Yeah.
Okay. All right. Keep it going. Keep it going.
Can I use the restroom real quick?
No, just wait. Yes, as soon as we're done with this, you can go. Okay.
It's been 30 seconds.
All right. Can I start?
No.
Yeah.
No.
No, not yet.
Okay, yeah, you can go.
Still going. Still going.
Oh, wait a minute.
Nice tune.
You betcha. See, it gets stuck in your head.
Who's singing?
Do you guys know the song Bohemian Rhapsody by Queen?
Yes, we sang
Yeah.
that. Mr. Richard, we sang that for choir once.
Nuh-uh.
Yeah.
Really?
You know, I could play it on
I have a calc version of that.
Oh my god.
Yeah, but what?
Julius is already done.
A calc version of that.
Oh.
Just kidding.
Mhm.
I could play it
Yeah.
on
It talks about
guitar.
limits and derivatives and stuff. It's a math song.
I might learn to play the guitar. I can play on the guitar a little bit. Well,
So anyway.
I learned
All
it
right,
myself.
here we go. What's A? Isaac Mackin, what's A?
1,
1, what's B?
2,
C is
5.
5, you betcha. B squared.
A reminder, picture retakes are tomorrow. If you need a picture packet, those are on the table outside of the office. The travel uniforms for basketball.
I'm still writing, so keep going.
Those are here in the office if you need one of those. Those are due back by tomorrow. The basketball tournament is tomorrow. The first high school game will start as scheduled at 3:15. But the first junior high game has been pushed back to 3:45. Any FBLA member that did not get a chance to sign up to bring something can still do so. Anyone is welcome to come watch. You will have to pay admission, but you get a free meal. The buses are gonna be out back, however, we can't go out that back door by Mr. Brown's room. We need any bussers to please use the dumpster doors to go out to the buses today.
The ones in between the locker rooms.
All right, all done. Okay, negative 16. Did you get that for your discriminant?
Yes.
Yes, perfect. No solutions. Why not?
Because it's negative, you can't take the square
You can't take the square root of a negative. All right, let's now. This is kind of frustrating for kids sometimes. We just said that there was no solutions. However, in the next box, they say find the solution. So even though it has no solutions, we still have to find the solution, but it will be imaginary, right? So we still have to do that. Negative b. What will that look like?
So it'd be -2.
Negative 2 plus and minus the square root of negative 16 all over 2 times 1. Okay, so let's figure out what some of this stuff means in here. 2 times 1 is just 2, but what is the square root of negative 16?
It's 69.
The square root of 16 comes out as a nice number, right? That's 4, but it needs an I on it because it's negative. Exactly. Yep. So it is negative 2 plus minus 4I all over 2.
Please have Alexis Case and Allison Lounsbury come to the office.
Okay, last thing before we graph it. We can write it like this, except all 3 of those pieces are divisible by 2, and you have to be able to divide all 3 of them by the same number, otherwise you can't reduce. You have to divide all 3 of them. It's like a triangular reduction, okay? So they all divide by 2, so this would become a negative 1. This would become positive 2, and this would become 1 on the bottom, right? If I divide everything by 2. So I have negative 1 plus and minus 2I all over 1, but
The 1 cancels out.
do you need the 1 on the bottom? No, it's like having a whole number, like 7 over 1, that's just 7, right? Okay, so we don't need to have the 1 on the bottom. We can just write it, our answer like that. Negative 1 plus and minus 2I, right? Negative 1 plus and minus 2I. Okay, so the graph of this thing, what the heck? We don't have any solutions, and I don't know how to graph this right here.
The y-intercept is 5.
We do know the y-intercept is 5 because this number at the end is positive 5. So let's do that. 1, 2, 3, 4, 5, right? Up here. Okay, and I said in my 6th period class, I said, okay, well, we know that he's touching there, right? And he is a smiley face, right? But he doesn't come down and touch that x-axis. So he could look like this, right? Or he could look like this, right? Or he could look like this, where that's the vertex, right? Okay? So how would we figure out what he looks like? Negative 1 is the
We plug
what?
in 5 for 0.
Negative 1 is the negative 1, 4 is the vertex actually, right? Okay, so if you do the negative b over 2a stuff, right, and then plug in, Tate did that for us. 6th period. Tate did that for us. He got negative 1 comma 4, and so this is what our parabola looks like. So thank you, Tate, for doing that, and Mackenzie did part of it. She said negative 1. Okay, all right, good. You have him graphed. All right, everybody say bye, Michael and Riley.
Bye, Michael. Bye.
Goodbye.